IOStats. This section of the AWR report provides an overview of input-output I/O statistics, which are crucial for understanding the performance of storage subsystems. It provides a detailed breakdown of I/O activity and helps to identify areas of concern and optimize storage and I/O performance. IOStat by function summary. This section categorizes I/O statistics based on different functions. Functions may include reading, writing, etc. This breakdown helps in understanding which types of I/O operations are consuming more resources. IOStat by Filetype summary. This part categorizes I/O statistics based on different file types. For example, data files, control files, redo log files, etc. Understanding which file types are generating more I/O can be crucial for troubleshooting and optimizing performance. IOStat by function/filetype summary. This combines the two summaries mentioned above. It breaks down I/O statistics based on both functions and file types. This provides a more detailed perspective on I/O patterns in the database. Tablespace IO Stats. This section provides I/O statistics at the tablespace level. It helps identify which tablespaces are experiencing higher I/O activity. By understanding which parts of the database are generating more I/O, administrators can make informed decisions about storage optimization. 5. File I/O Stats. This section provides I/O statistics at the file level. It helps identify which individual database files are generating the most I/O. It's valuable for pinpointing specific files that might be causing performance issues. Column headings of some of the charts include: function name, type of function performed by the database. Reads, data, total volume of data read by the respective function. Recs per SSE, number of I/O requests, reads or writes, per second. Data per SEC, amount of data processed per second. Writes, data, recs per SSE, data per SEC. Writes, data, total volume of data written by the respective function. Recs per SEC, number of I/O requests, writes, per second. Data per SEC, amount of data written per second. Waits, count, number of times the function had to wait. Average TM, MS average time spent waiting, measured in milliseconds. Total reads, the sum of reads from all functions. Total writes, the sum of writes from all functions. Total requests per second, the total number of I/O requests per second. Total data per second, the total amount of data processed per second. Functions include: direct reads, indicates the volume of data read directly from disk without using the buffer cache. Direct writes, represents the volume of data written directly to disk. Buffer cache reads, displays the amount of data read from the buffer cache. Others, encompasses miscellaneous I/O operations not falling into the specified categories. LGWR, log writer, represents I/O operations related to the log writer. DBWR, database writer, reflects I/O operations related to the database writer. Data pump, indicates I/O operations related to data pump activities. Streams AQ, advanced queuing, represents I/O operations related to streams AQ. Reads, data, recs per SSE, data per SEC. Column headings of some of the charts include: tablespace, specifies the name of the tablespace for which the I/O statistics are reported. File_name, specifies the file name of the data file. Reads represents the total number of reads performed on the specified tablespace. AVRDS/S, average reads per second, indicates the average number of reads per second for the tablespace. AVRD, MS, average read time in milliseconds, represents the average time, in milliseconds, taken for each read operation in the tablespace. AVBLKS/RD, average blocks per read, indicates the average number of blocks read per read operation in the tablespace. 1BKRDS/S, single block reads per second, represents the number of single block reads per second for the tablespace. AV1BKRD, MS, average single block read time in milliseconds, indicates the average time, in milliseconds, taken for each single block read operation in the tablespace. %opt reads, percentage of optimal reads specifies the percentage of optimal, cache, reads compared to the total reads in the tablespace. Writes represents the total number of writes performed on the specified tablespace. Writes average/s, average writes per second indicates the average number of writes per second for the tablespace. AV writes, ms, average write time in milliseconds represents the average time, in milliseconds, taken for each write operation in the tablespace. Buffer waits indicates the total number of buffer waits for the tablespace. AV buff WT, ms, average buffer wait time in milliseconds represents the average time, in milliseconds, a session had to wait for a buffer in the tablespace. For high-performance systems, you generally want to minimize physical I/O by maximizing cache hits. This means that a higher percentage of reads should be optimal reads from the buffer cache rather than physical reads. A high rate of physical writes may indicate a need to optimize write operations. Lower values for average read and write times are generally better. This indicates faster I/O operations. A lower average number of blocks per read suggests more efficient I/O operations, as it means that each read operation fetches fewer blocks. This can be beneficial for reducing I/O contention. Single-block reads are common for index scans. The rate of single-block reads should be considered. A low number of buffer waits is desirable, as it indicates minimal contention for buffers in the buffer cache. Lower values for average buffer wait time are preferable, as they indicate shorter waits for access to buffers. A higher percentage of optimal reads is desirable, as it indicates that a significant portion of reads can be satisfied from the buffer cache, reducing the need for physical I/O. If the Tablespace IO report seems to indicate a tablespace has I/O problems, use the File IO Statistics report to drill into the data files of the tablespace in question. You will see statistics like average number of read requests per second, average read time in milliseconds, write waits, number of buffer waits and average wait time in milliseconds for buffer waits. These values indicate read and write operations of Arch, buffer cache reads, data pump, DBWR, direct reads, direct writes, LGWR, RMAN, recovery, SmartScan, Streams AQ, XDB, and others. If buffer waits, tablespace I/O, for a tablespace is greater than 1000, you may want to consider tablespace reorganization in order to spread tables within it across another tablespaces. AV buff WT, ms, is important as in a system with low DML activity and a well-configured buffer cache and I/O subsystem, there should be almost zero buffer waits. Buffer wait helps us see how much sessions/processes have to wait for a buffer which is read into the buffer cache. AVRD, ms, columns must not exceed 20, otherwise it worths involving your OS team and hardware vendor to investigate the I/O bottleneck. If a data file consistently has average read times of 20 milliseconds or greater than, the queries against the contents of the owning tablespace should be examined and tuned so that less data is retrieved. If the tablespace contains indexes, another option is to compress the indexes so that they require less space and hence, less I/O. The contents of that data file should be redistributed across several disks/logical volumes to more easily accommodate the load. If the disk layout seems optimal, check the disk controller layout. It may be that the data files need to be distributed across more disk sets. The buffer pool statistics and checkpoint activity sections of the AWR report provide insights into the performance of the Oracle database buffer cache and the activity related to database checkpoints. Buffer pool statistics. This section shows information related to the performance of various buffer pools. Buffer pools are areas in the System Global Area, SGA, that is allocated to cache where frequently accessed data blocks queries. The size of the buffer pool is configured using the db_cache_size. The buffer pool can be multiple types such as default, keep, recycle. Buffer pool advisory is physical blocks read, not read requests, into the cache since instance startup. $buffer_pool_statistics displays statistics about all buffer pools available for the instance. Pool. This indicates the type of buffer pool. It can be default, keep, recycle. Number of buffers, the total number of buffers in the buffer pool. Buffers are units of memory where data blocks are cached for efficient access. Pool hit %, buffer pool hit %, the percentage ratio of buffer pool hits to the total number of buffer gets. Buffer gets the total number of requests for data blocks. It includes both successful hits, served from the cache, and misses, requiring physical reads. Physical reads the number of times data blocks had to be read from disk into the buffer pool. Physical writes, the number of times modified, dirty, buffers were written from the buffer pool to disk. The disk I/O incurred by write operations. Free buff wait, the number of times processes had to wait for free buffers. This indicates the degree of contention for available free buffers. Writ comp wait, the number of times processes had to wait for write completions. This measures the waiting time for write operations to complete. Buffer busy waits, the number of times processes had to wait for a buffer to become available in the buffer pool. A sufficient number of buffers is important to accommodate frequently accessed data pages. A sudden drop in the number of buffers may indicate a configuration issue or a sudden increase in demand. A high buffer hit ratio, close to 100%, is desirable, as it indicates that most queries are serviced from memory. Reducing the need for disk I/O, buffer gets is the total number of requests to access a data block in the buffer pool. A high number of physical reads may suggest that the buffer pool is not adequately sized. A lower number is generally better, as it indicates fewer reads from slower disk storage. Frequent physical writes may indicate a high rate of data modification or inefficient cache management. Frequent and non-zero value free buffer wait waits may indicate contention for buffer pool resources and may require adjusting the cache size. High write complete waits values may suggest that disk I/O is a bottleneck for write operations. Frequent buffer busy waits may indicate contention for specific buffers. If a buffer pool shows excessive numbers of dirty buffers inspected and high amounts of buffer busy waits, then it probably needs to be increased in size. Checkpoint activity. The checkpoint activities section of the Oracle AWR report shows information related to various types of checkpoint writes. A checkpoint is a mechanism used to ensure that all modified data blocks in memory, in the database buffer cache, are written to the data files on disk. Checkpoints are initiated to reduce the time it takes for Oracle to perform instance recovery in case of a failure. Checkpoints can be triggered manually or automatically by the Oracle database. There are two main types of checkpoints: fast checkpoint, incremental checkpoint, complete checkpoint. The frequency of automatic checkpoints is influenced by the initialization parameter fast_start_mttr_target, mean time to recover target. db_cache_size, log_checkpoints_to_alert, and fast_start_mttr_target parameters can be adjusted to tune checkpoint behavior. During a checkpoint, the database writes data blocks to the data files but does not necessarily write all the redo log entries to disk. The redo log entries related to the changes made to data blocks are written to the redo log files. MTTR writes the number of writes performed as part of the mean time to recover (MTTR) process. Log size writes the number of writes due to the log file size reaching a threshold. Log CKPT writes the number of writes performed during log checkpointing. Other settings writes of this include writes triggered by other checkpoint-related settings or configurations. Autotune CKPT writes the number of checkpoint writes automatically tuned by the system. Thread CKPT writes the number of writes during thread checkpoint operations with specific threads in a multi-threaded or RAC environment. Monitoring checkpoint activity helps to understand how often and under what circumstances checkpoints are occurring. Checkpoints are crucial for ensuring data consistency and recovery in case of a failure. Lower values for mean time to recover, MTTR, are generally better. Lower MTTR values indicate faster recovery. In an optimal scenario, you would want to minimize unnecessary log file switches. Regular and small log file switches are preferred over infrequent and large switches. A lower values for all other metrics is generally preferred for optimal performance.